Right, so it all started with accuracy. And accuracy means how close a measurement is to target. I'm just going to summarize it. If you want to go through and look it up, you can do so. But accuracy is how close a measurement is to the actual value. Right? Target is like our actual. So what can it can be affected by the scale, if it's inappropriate. And by the way, now I can tell you that the scale is really the precision. At first I didn't talk about it because at the very beginning we didn't really know about precision yet, but the scale has to do with the precision. It can have to do with units, whether or not you're using standard units. So if you're using a handspan, not good, right? If you're using meters, that's standard, right? Cups, teaspoons, tablespoons, all of that is as well as inappropriate use of device, okay, inappropriate, or so these are all little bullets, right? And you can also talk about damaged device. But please don't say damaged device if it's a word problem. You have to be specific to that scenario. Like a ruler. A ruler may have been bent or may have been cracked, or maybe you left a cup outside in the sun and it's all warped. Like, be specific. Don't just say damaged device, okay? So that's that. Then we talked about precision. This is on page 66 if you're just joining us. It is the smallest increment of measuring device. Uncertainty talks about margin of error, okay? How much it can be off by. I'll just leave it like that. How much, it kind of tells us how much we could potentially be off by and with our measurement. Okay? And it is uncertainty, mathematically, uncertainty is precision divided by 2, right? So that's something you need to know. And so there's some examples here. I hope you know this one already. But if you're having a reading, okay, that's 0.00, we focus on that second decimal, so the precision is 0.01 of a centimeter. Uncertainty, therefore, is half of that, 0.005 of a centimeter. Okay, so that's one example. The other one would be if you have a ruler, starts with 0 and it goes up by 20. Folks, it's from marking to marking that you're looking for. In this case, every marking is attached to a number. So in this case, it would be easy to just say that the precision is 20, let's say centimeters. Let's say this ruler is in centimeters. Uncertainty, therefore, is plus or minus 10 centimeters. Okay. It gets a little trickier, though, if you want another ruler. I'm going to use the exact same numbers, okay? I'm going to use the exact same numbers. I'm going to attempt to go up by 20. However, we're going to introduce a little added level of difficulty. So between 0 and 20, I'm going to introduce, I'm going to have 3 markings. See tomorrow. Right, so there's 1, 2, 3, 4 gaps. That's what I want you to have. Same with the other ones. and to have 3 markings so that there's 4 gaps. In this case, I would strongly suggest, I mean, you can guess and check, but I would say this is your high, this is your low, right? You pick these 2 numbers, and then it's 40 minus 20. It works every time if you're careful. And then you count 1, 2, 3, 4 gaps, right? There's 4 gaps there. So you just go divide by 4. So 40 minus 20 is 20. Divide that by 4, you get 5 centimeters. I am using nice and round numbers, but these could be really small, okay? You have a calculator to help you out. The uncertainty, therefore, would be 5 divided by 2. That'd be plus or minus 2.5 centimeters. And so this goes without saying. I think you guys all have figured this out already. I'm going to cut this off there. And then we'll talk about for instance, let's say something measures a stating measurement plus or minus uncertainty. So let's say I ask you, hey, state a measurement in this format. So for example, let's say that something measures 27.1 grams, okay? And I ask you to state it in this format. You have to first get your precision out of that measurement. We're not told that the device has a certain increment. We're not told that, okay? If they tell you, you got to go by that. This thing is 0.1 grams increments, so then that would be our precision. Here we have to get it. So we know that it's 0.1 grams. The uncertainty from that is half, right? So that'd be 0.05 of a gram. So now we're ready to state it. We're going to copy paste this measurement, and now we're going to tack on the uncertainty that we've figured out. So you got to be able to take a measurement and write it like this. It's just combining what we've done before, right? It kind of forces you to find the precision, find the uncertainty, and then just tack it on at the back. Never go plus or minus precision, okay? That is, unfortunately, you're not going to get any marks there. You got to figure out your uncertainty, and then from that, there is a maximum and a minimum. And I know this is a little confusing. It's like, isn't this the same with tolerance? Don't you have max and min with tolerance? Yes, it is true. But in tolerance, we're interested in what's the lowest allowed and what's the highest allowed, right? That's an allowance. Whereas here we're saying, because our device could be off, there's a chance that this thing measures, on the high end, and it could measure on the low end something, right? We're not sure about it. So it's a little different. So what happens when you add these two? You get 27.15 grams. If you subtract, you get 27.05 grams. So basically add and subtract to get that. So read the question carefully. Obviously, if it's max, you're going to want to add. If it's a min, you're going to want to subtract. Okay, so that's that. Next, I will talk about combined measurement and uncertainty. And so the example here is, let's say you have a bucket, and the amount that is in the bucket, I'm just making this up right now, is 3.50 liters plus or minus 0.2 of a liter. And you have a cup that has half a liter in it, plus or minus 0.1 liter. Like you literally have the measurement and the uncertainty already like that. Let's say we are removing, assume we remove a cup from bucket. What would you do in this case? So in this case, I simplified it to a certain degree. There's that big bucket, and we have cups that we're removing. We're always I'm gonna use a color here, maybe to bring this to life. Because we're removing, we're subtracting the actual measurements, but we always add the uncertainties. We add no matter what. Okay, so 3.5 minus 0.5, that would be 3 liters. I'm going to stick to that. If you just put 3, that should be fine. And then here you add the uncertainties as well. So that's 0.3 of a liter. So that's what we mean by the combined, how much is left in the bucket. So that's kind of like combining the measurements. In this case, you subtract. And we would have to add the uncertainties like so. So you got to be able to figure that out. And of course, we could be removing 10 cups. And you'd have to go this times 10 and this times 10, right? And then you would subtract and add. No matter what, you add your uncertainties, guys. Okay? No matter what. What else do I have to say here? I think I'm going to leave this part as is. And maybe if we have time, I'll use that bottom part there to add more. But let's go tolerance real quick here. On 67. So I'm going to go to 67. Are you still copying? Sorry. If you're still copying, finish copying. That's fine. I'm going to pause here. We still have a little bit of. So another example would be a bag weighs, let's say it weighs 25 pounds, okay, plus or minus half a pound. So sometimes you have to figure out the uncertainty for that bag. We know that the precision is 1 pound, so the uncertainty would be half a pound. So I just did that quickly, right, for you guys. Determine the weight of, let's say, 70 bags. So now you're doing the same thing. You're just adding the same amount over and over again. So my suggestion would be just go 70, multiply it by 25 pounds. Figure out what that is. Then take 70 and multiply it by the half a pound, right? The uncertainty of every single bag. It's going to compound, right? It's going to keep adding 70 times. So this is 1750 pounds is the combined weight of all the bags, okay? And then half of 70, what's that? 35, right? This is the combined uncertainty. And this is the weight. So let's state it. They most likely want you to state it like this. 1750 plus or minus 35 pounds. Like I'm thinking of airplanes when they fill up your luggage, right? The belly of the plane. they keep on adding luggage and luggage and luggage and luggage, right, into that big bin. So at some point, your measurement is going to be off, right? So they have to account for that. The airline has to account for that. So various versions of this, really just got to be careful what's happening. When you're removing, obviously you subtract the amounts, but you always add your uncertainties. No matter what, you add them, okay? That's important. Let's go to 67. I'll just talk about tolerance. And then we can still have some time maybe. Tolerance, in terms of definition, it is the range of acceptable values. Okay? Peace can still be used for its intended purpose. Not it needs to be discarded, right? Mathematically, remember this one, have this on your study sheet. You go max minus min. That's how you find out what the tolerance is as a number. Okay? It's the difference. Always remember, when we're in the tolerance camp, as soon as you see the word tolerance, there's the lowest that we accept, there's the highest value that we accept. The difference between the highest and the lowest is what we call tolerance. And the nominal can be anywhere in between. The nominal could be right on here. That's the target. The nominal could be right on there, or it could be somewhere in between. Okay? So keep that in mind. There are 4 formats that we kind of followed. Okay, I'm going to say this, guys. These 4 formats are just in case I ask you to rewrite it in a certain way. But I will show you what I mean by that in a bit. Max, min is the one. That's one format. The other one is max plus 0 minus tolerance. And all of these are going to be replaced with numbers. The other one is minimum minus 0 plus tolerance. And the last one is nominal plus or minus half of a tolerance. You have to be able to write them accordingly. But this is my advice to you. Always extract the following. We're almost done. Always extract the following. I'm going to do it in this order in particular. I would say figure out the nominal, figure out the max, figure out the min, then figure out the tolerance. Okay. If you can do that, then rewriting it in these formats that I've mentioned above is a piece of cake. Okay. So example, I'll give you the example. It's annoying when they do that to us, but the province has done it. So let's say 45 plus 0.8 millimeters minus 0.5 millimeters. And you're like, wait a minute. What's up with this 0.5 or the 0.8? Mr. Erickson, I thought one of them has to have a 0, right? Like when it's like this. Don't worry about that. This is just in the format that I want you to write it in. But these four you can extract no matter what they throw at you. Okay? So what is our nominal here, guys? Need to wake up a little bit. What's a nominal if I were to pick one of these three numbers? It's always the one that's at the front, always. Okay? So 45 millimeters. The max, you just go this plus whatever is up here. You add them up. So that's 45.8 millimeters. The minimum is this minus that, whatever is subtracting, right? We subtract. So that'll be what? 44.5 millimeters. And what's the tolerance? That one you should be able to do. You subtract the two. Okay. And what would that be? 1.3? Somebody double check because it's Monday, right? 1.3? So once you extract this, once you've done that, right, you got it from here, you filled in your little inventory. Now I could ask you to write it in any of these formats, right? So write like this, max, min, like I will actually tell you, write it like that. You're like, okay, no problem, I have my max and my min, so we just do that. Done, right? This is all you had to do there. Okay. There's just one problem out of all these four. One of them doesn't give you the nominal, which is this one right here. So if you're trying to extract it, you have to do a little bit of extra work with this one. So I kind of made a mistake. I should have added that right here, but I will just make a note here. Nominal is max plus min divided by 2, okay? Very important. Can you also write this down? Because I will add that. I checked what the province wants you. Sometimes they call this a midpoint. And if you think about it, when you add the max and the min divided by 2, you're finding the middle between the highest and the lowest values. I will highlight that even, so you can't say I didn't warn you, right? So you have to do a bit of extra work when you get one of those. And I'm guaranteeing you will see at least one where you're going to need this, okay? So make sure you know how to do it. Do you remember your insurance questions for vehicle finance? Because you're listening intently, I'll help you out a bit. What are the 4 things? I'm not going to write them down. 4 factors, risk factors, I should say. You just go look them up. Affecting, right, that affect your auto pack premium. You may want to check that out. You also want to check out loan payments. Just make sure you have the formulas for loan payments. What was it, page 32 or something in that booklet? There's a bunch of formulas on how to calculate a loan payment, like a monthly payment. So know how to do that. And I think that is it from a previous unit. Just got to make sure you know how to do that. Okay. So look this up if you wanna. Like you're looking at 3 to 4 marks out of 45. So it's almost 10%, right? Like you wanna you want to be able to look that up and just make sure it's on your study sheet. Okay? And if you want the bonus for the ACs, you do the 3 ACs, it's like up to 30% bonus on your overall AC mark so far.